I talked to Dee Dee, how should I frame this? And she said, well, our audience is primarily managers, do your best. I'm really a newbie, so I can see even just through the course this afternoon that there are lots of other cool things that we could have talked about. So, but I'd already committed over lunchtime to my presentation, so we're gonna have to stick with it, and happy to take any questions or concerns after. That's really big, wow. Okay, well, so, we've really been hearing about this all afternoon, of course, and Janet did set me up nicely for this, that when we think about how we harvest landscapes, how we manage landscapes, there's a lot of effects and implications for when we go in and manage a stand. From habitat to carbon to lichens to everything else. Those in turn affect societal perceptions, which can affect policies and feedback in. But as I think Janet argued pretty well, knowing the cumulative effects of these things across landscapes is relevant because a lot of these processes work across landscapes. Carbon, habitat, all of those things are relevant at a stand scale, but they're also relevant when you look at the aggregation. And so what we want to look at, in part, is we want to understand how much harvest was going on, where was it happening, when, who was doing it. And again, it's the cumulative effects that I think we have to monitor to sort of aid in some of the discussions that we've been talking about. Satellites are good for that because they've got some good things going for them, and I'll be the first to say that there are also some disadvantages. Consistency is really the big one. As you might expect, if you have a satellite looking from 700 kilometers up, it takes the same picture over the whole landscape. And it's fairly objective. It's just measuring reflected sunlight. It has no, no bias as to what the outcome should be. The other nice thing about satellite imagery is that it's inherently spatial. So if you're a manager and you have a landscape and you've got maps, you can take in your maps and you can connect them up to the imagery and say something, hopefully, or at least ask questions. But you can't do some things. For one thing, with the kinds of satellite imagery we're talking about, you can't see through the trees. There are technologies like LiDAR that allow you to see between the gaps in the trees, and that's another whole technology with a lot of promise for structure management. There are technical challenges, as with anything, and if you're used to measuring things on the ground, satellite's not going to tell you that. There's a trade-off. You get a huge expanse of information, but less richness at any one point. None of these are probably huge surprises, but they certainly set the stage for how we can use it. We're looking at consistency across big areas. We know we're going to sacrifice some detail at the plot level. So my sole goal today, my take on trying to meet what Dee Dee talked to me about, is to describe a new way that we're using satellite imagery to do this. And Janet mentioned a little bit of it in the last talk. And then use this to look at some patterns in Western Oregon. So to set the stage, for those of you who don't spend all your days and nights thinking about satellite mapping, Landsat is a satellite that's been up there forever. It's the longest running sort of continuous satellite measurement out there, run by the US government, and it has a lot of things that have made it very useful for mapping through time. We're not the first people to use it. We certainly won't be the last. It continues to sort of plug along. Even in our own lab, we've done a lot of work looking at forest disturbance in Oregon. Some of you have probably even used this. These are maps of change. We call them change detection maps. They're based on Landsat. And if you'll notice, if you can see sort of on the right-hand side, somewhere there's probably a pointer. I'm not going to. I'll just get in trouble if I do that. On the right-hand side, you can see that you can map the whole state, but you can also drill down and look at individual management units. So that's a nice kind of compromise in scales. But if you look at the legend, the maps that we had been able to make in the past were what we called interval-based maps. You look at time 1, you look at time 2, you compare them, you say what's changed. And there's a lot you can do with that, but what you miss is you miss that annual time step, which is important for a lot of economic and certainly habitat cycles. And it also makes it difficult to pick up some kinds of disturbance, which I'll get to in a second. So the new approaches that we can do are sort of facilitated by, of all things, a policy decision by the US Geological Survey to make Landsat data available to all of us, actually to anybody on the globe, for free. And importantly also with the same kind of processing recipe. Makes it a lot easier to work with, and of course if they're free, then you really can unleash your efforts and your time developing methods as opposed to just paying for data. One of the nice things about the approach that we're using now, and I've got some examples here, is that we can drill through, if you will, drill through a time series, look at the life history of individual plots on the ground. So this satellite has been going around since 1984, and it's been looking at the planet. Every 16 days, your plot of ground has been imaged by this thing. It's a little scary in some ways, but luckily it's some very big pixels, so there's not anything revealing that can be seen, except for these trajectories. And so I've got 3 pixels, just 3 pixels shown here in the lower left on that graph. And the colored lines represent what the satellite saw. The black line represents the algorithm that we use statistically to sort of smooth those out. And the point of the algorithm is to say, well, what's the sort of important shape of that life history? Was that a pixel that saw growth and then a partial harvest? Was it a fire? Was there just growth going on? Were there a whole series of other things that can happen? What's nice about this, though, and relevant for today, and I'll get to this in a second, is that if you have 15 examples of what a forest looks like when it's relatively stable, you're much better able to detect when there's an anomaly, much better than if we just use this interval-based approach. So we're able to finally enter into this discussion of density management and partial harvest with this approach. What we can do, though, in terms of how we make maps, we note when something happens, for example, a big disturbance, and we can actually look at how much it dropped. And today I'm just going to talk about those things. I won't even get into a lot of the ways that we feed data to Janet's group, for example. And in doing that, for example, we can map forest disturbance for big areas like the Northwest Forest Plan. There's an insane amount of data that underlies this map, actually. I don't even want to go into that. And the free data and free, cheap computers allow us to do that. But we've gotten past that. It's sort of a non-issue now. We can process it. It takes a lot of time, but we know how to do it. And there are a lot of interesting patterns here. We can summarize them. This is from a recent paper of ours as well. On the upper right, you've got years along the x-axis. We're looking at just counting up how much disturbance has happened by private, state, and federal ownerships in the different bars. They're stacked bars. And so you can see how much is going on, how much disturbance is happening over time. If you want to look at sort of the cumulative effect, this is what I find a little easier to view. That's on the lower right. And so you can see these trajectories going through time. The x-axis tells you when something happened. The different dotted lines tell you who was doing it. So the rate there will give you a sense for how much disturbance is going on as a function of area. So the amount of forest disturbed versus the amount of forest. And so the top line, the dotted line going up at a pretty steady pace is private lands. The very bottom line, the black one, is federal protected lands. And in between, we've got a sort of diversity of state, tribal, and federal non-protected lands. And I won't belabor this, but some of the conclusions you can reach from this, even from a fairly simple summary of this stuff, nothing really hugely surprising for those of us who know how forests are managed here. Private lands saw forest disturbance happening at a maybe remarkably steady rate over all of those economic cycles in the last 23 years. Disturbance on federal matrix lands slowed after the Northwest Forest Plan, so that dotted line actually kind of leveled out if you drill into that legend a little bit. Disturbance on tribal lands intensified actually after the mid-1990s a little bit, and fires, and that black line on the bottom, as Janet just alluded to, on protected lands, end up bringing those lands in terms of percent disturbance much closer to their matrix counterparts in federal lands. Kind of interesting. And just to give you an example, we can even drill in sort of more spatially concise units. And so we have here splitting it up by state. So Washington, Oregon, California across the top. Different ecoregions, and I've just picked a couple here, Coast Range and Cascades. The pie chart tells you who's been doing the harvest, the disturbance. If you can see, it's a little hard on the screen, I guess, but there's a bar chart on the left that shows the total area of forest in each of these ecoregions by state, and then the darker part of that bar is how much was disturbed. So in this little graph, you get a sense of how much forest there was, how much was disturbed, and then who was doing it. And just some interesting things that can be drawn even from a fairly cursory analysis here. For example, in Oregon in the Cascades versus Washington in the Cascades. a much greater proportion of the disturbance happening in forests in the Cascades in Oregon was on federal lands than in Washington state, where it was on both private lands and state lands. There are clear implications there for, number one, how you're going to manage habitat across the landscape. Where do you need to apply a policy if you actually want to have an impact? And also for who's going to make the decisions that are going to affect disturbance rates. But what we're really interested in this kind of context is about the intensity, sort of the magnitude of harvest. And as I mentioned earlier, one of the really key things is that we can pick up these subtle disturbances much better. Now, this is not a panacea for going out on the ground, but because we can see this huge area, this greater ability to distinguish subtlety is really kind of critical. So I have two pictures here. These are air photos, but then overlaid on them are maps. And on the left, in yellow, there are these polygons that our algorithm found for disturbance. And the dark shaded yellow are what we found, but they were earlier than the air photos, so they're a little confusing. We just want to focus on the open polygons. The ones on the left are clear cuts. There's one on the right. Now, it might be kind of hard to see, but it's actually a partial harvest. You can see the skid trails when you look at the air photo. That's picked up and outlined in purple. This is just sort of to show you that, in fact, we can detect these low magnitude harvest events. And we can, I think I'll even skip going over the details of this, but we can detect these at a fairly decent rate, both what we're calling medium and low harvest as compared to what a trained interpreter would look at, and have agreement levels, medium of 86%, if you want to think of those as percentages, and 60 for the lower. So again, we're not getting everything, but these are much greater than we've been able to do before. So for this study, what we looked at was just looking at Western Oregon, and sort of summarized these different intensities, intensities of forest harvest across these different ecoregions. So we have 4 provinces I'm looking at: Coast Range, Klamath, Cascades, and Willamette Valley. And then different ownerships. And there wasn't enough native land in here to really bring in. So I'm just looking at federal, state, and private. And as those of you who are familiar with this landscape know, that this is not evenly distributed. Most of the Cascades is in federal. The Coast Range has more of a melange of private and state and federal. And the Klamath is sort of more just private and federal. So we're going to look at a couple different things here, but basically they all kind of boil down to this. How did harvest intensity vary by time across ownerships and ecoregions? We think that partial harvest should be increasing based on everything we know about management in the region. So what we did is we went back to our original map. We removed fires. I can go into detail about this if you'd like offline. We stratified by harvest intensity. This gives you sort of a sense of what that means on a landscape. This is done by Tiller in the Umpqua, and I've zoomed in a little bit on the upper left. So some harvests in the light pink are all basically clear cut, whereas some harvests in the dark pinkish purple are all very low intensity, and then there's some that are kind of a mix. So we're picking up a full range of different intensities, and then we summarize by ecoregion. And I just have to say, these are also hot off the press, so you were the first people to lay eyes upon these results other than myself, including my co-authors actually, so I guess I should stand by this by myself in case anybody has a problem with it. They helped me get to this point, but I was able to make these graphs for you. So one of the interesting things, so this is the Coast Range province, and I want to point out first that these things have different scales. I know I hate doing that in some levels, but we're actually interested in the relative amounts within a given ownership. And so just pay attention to the fact that these are not comparable across different ownerships. We're looking at these different colors, and the colors correspond to low, medium, and high, and these are stacked. And so this is the time on the x-axis, how much disturbance occurred in these different categories. And what can we see from that? Well, on the right-hand side, we've got forest harvests on federal lands. You can see, lo and behold, in the late 1980s and early 1990s, something happened on federal lands. I don't know, the harvest stopped. And on state lands in the Coast Range of Oregon, we see starting in the mid-1990s a lot more harvest. But that harvest, as you can see, was primarily in these medium and low intensity categories. Private lands, no drop in harvest as we would expect, but as harvest rates increased since the mid-1990s, it looks like more and more of those are in this high intensity category. And lo and behold, if you actually plot these as a ratio, we've got federal, state, and private in different colors here. Private is in the cyan color, which is very low to begin with, meaning the amount of low intensity to high intensity is fairly low, and it drops over time, whereas on federal and state lands, that number is going up, meaning there's more low intensity harvest. So I've got results for each of these provinces. I won't belabor them because of the time, but essentially the story is very similar. Private lands, we see the same thing happening all over the region as we would expect in the early 1990s. But interestingly, on public lands and federal lands, and private lands, the intensity seems to be going up over time. Same thing happening in the Cascades. Where harvest is occurring on federal lands, it's less intense. It's not happening nearly as much, of course. And also in the Klamath, where there's a lot of noise because there's not much in the state lands, but if you look at the private lands again, the proportion going into high magnitude is definitely higher. So we can summarize all this at a landscape scale and come to some conclusions, observations, let's say. Harvest rates on federal lands are what we would expect. On state lands, they're increasing in the Coast Range, and on private lands, they've increased after the mid-1990s. Again, probably consistent with what we would expect, but we actually have an objective, consistent measurement to show it now. In terms of intensities, federal lands and state lands, we have more medium and low intensity harvest happening all over. And on private lands, again, this relative rate of high intensity to low intensity is increasing. So there's a tendency, for whatever reason, I'd be curious to get your thoughts on this as to what's happening on private lands, especially after the 1990s. And that is it. These are my co-authors. Decided to actually show pictures of them just so you can envision them standing in the room with us. And also we have support from the effectiveness monitoring folks. And for the algorithm development, we've been working on programs with NASA and with the Park Service too. So thank you. Thanks again for sticking it out. I appreciate it.